Okay, so I'm going to go ahead and get started. We're really delighted to have everyone join us this evening for our April virtual meetup for Data and the Greater Good. And in these challenging times, I guess we're being asked to step up and find new ways to have community virtually. So delighted that all of you have joined us for this meetup and talk with Brooke Bateman, scientist from the Audubon Society. I'm Elaine Gamble, and I am the organizer for Data and the Greater Good, where our mission is the use of data, digital analytics, digital transformation, data innovation in nonprofit organizations or those with a mission focus. And we've been privileged to have some of the most renowned organizations in the world joining us to talk about how they're using data in new and innovative ways to advance their mission. The Metropolitan Museum of Art, the Whitney Museum, the Museum of Modern Art. We've had Donors Choose talk to us. Most recently, Global Giving, the 92nd Street Y, and the New York Public Library, among others. And we are honored to have with us tonight Brooke Bateman from the Audubon Society that will talk about the impact of climate change on the bird population. Before we go into her talk, I want to tell you a little bit more about Brooke. Brooke is Senior Scientist of Climate at the National Audubon Society. She leads the climate science team, collaborating with scientists, volunteers, and Audubon's climate initiative team to develop research focused on climate and the conservation of birds and the places they need today and in the future. Birds bring us so much joy, yet they are at risk for survival because of the impact of climate on the bird population. In Brooke's role, she has led a team in developing the 2019 Birds and Climate Change Report, and is also the director of the Climate Watch, where she works with community volunteers to understand how climate change currently affects birds in North America. Before joining the Audubon science team in 2016, she was a postdoc at James Cook University, the University of Tasmania. She's also been a postdoc at the University of Wisconsin, Madison. She received a PhD in zoology and tropical ecology from James Cook University and graduated cum laude from Boston College in 2003. Her favorite bird is the common loon. And it's really wonderful to have speakers that take excellence to the next level in what they do. So now, without further ado, I'm going to turn this over to Brooke Bateman from the National Audubon Society. Brooke?
So thank you for coming to this online event tonight. Unfortunately can't do it in person, but everybody understands. Tonight I'm going to talk about our report that came out in October, Survival by Degrees, 389 species on the brink, talking about the fate of North America's birds in a changing climate. So I'm going to give you a kind of a climate change 101 overview, and then I'm going to dive into the report itself. Well, first I'm going to talk about birds and climate change, and then the report itself and some of the ways that we've been using the data to get the word out on the issue. I don't know how many of you are bird lovers on the call or nature lovers. Surprisingly, there's some fantastic birding in New York City. I'm based on Long Island, but I know Prospect Park and Central Park and some of the other parks in the city are really great spots, particularly right now during spring migration. I know it might be tricky to get out, but in the next couple of years, make sure this time of year to get out and look for the birds around you. So climate is said to be one of the biggest issues of our time. And we've heard recently from the youth that they don't want their future to be compromised. And recently, over 11,000 scientists, including myself, signed on to a petition declaring a climate emergency or a climate crisis. I do want to sort of take a step back and understand that we are in another crisis right now with the COVID-19 pandemic, but they have similarities and something that we need to look for in the sense that this is another threat that is facing everybody globally. Nobody is going to be able to escape from climate change, just like everybody right now across the globe is dealing with the pandemic. So I just wanted to mention that to give that context, because I understand that we are going through other stuff as well right now. So this is a figure, two different figures that talk about that show you how global temperatures have continued to rise. So of the 17 hottest years ever recorded, 16 have occurred since 2000. So every year is getting hotter and hotter. And temperatures over the Earth's continents and oceans in 2016 were already about 1.1 degrees Celsius above the pre-industrial average, which is nearly 2 degrees Fahrenheit. So that means that we're already the majority of the way to this 1.5 degree warming goal that was set at the Paris Climate Agreement in 2015. And so this is a global temperature. Certain areas can have much higher temperatures. So a 1.5 degree temperature Celsius globally is actually much warmer in the United States. So what do we talk about when we talk about climate change? Climate change has happened for millennia. It's a natural process in the environment. However, things that are happening right now are not so natural. So this is just a plot that shows you the parts per million of carbon dioxide in the atmosphere from 800,000 years before present until present. And so we have these greenhouse gases in our atmosphere that actually help sustain life on Earth. We need these gases to help keep in the heat to allow us to have an atmosphere. However, when it shifts from a natural greenhouse effect into a human enhanced greenhouse effect, what we have is we have much more of these greenhouse gases in the atmosphere, including carbon dioxide. And what that happens is that more of this heat is trapped in the atmosphere and less of it can escape into space, so that we have much more heat in our planet. So it becomes a non-natural event. And so you can see here that we're at about 407 parts per million, which is much higher than the previous concentration of 300 parts per million. And what we've seen is that as carbon dioxide has trended up in the atmosphere, so have the global temperatures. And so there's a pretty strong correlation between carbon dioxide and temperature increases. So carbon dioxide is not the only greenhouse gas. I do want to mention that there's others. And this is the plot on the left is looking at carbon dioxide relative to the other greenhouse gases in terms of how much heat they kind of trap in the atmosphere, their global warming potential. And so methane has 25 times more potent, nitrous oxide is 300, and then fluorinated gases they're much, much more able to trap heat. However, carbon dioxide is the bulk of what's in our atmosphere. It's 76% from this figure from 2014. So the other are a much smaller percentage, but there's still something that we need to pay attention to. Another reason why the focus is often on carbon dioxide is because of this. This is the amount of time that these gases stay in the atmosphere, that they'll stick around. So methane is 10 years, nitrous oxide is 100 years, but carbon dioxide can stay in the atmosphere for over 1,000 years. And so it has this really long potential to continue to change the climate after it's put into the environment. And so that's the big concern. We're continuing to put carbon dioxide in the atmosphere, and it's not something that goes away very easily. So I know this is a busy graph. I kind of grabbed it from this paper down here at the bottom, but what I wanted to highlight is that the rate of change is something that is very unprecedented. And so this is looking at global temperatures and how they've changed through time. And what you need to look at is the way that the blue line, how fast it's going upwards in the amount of time. And so models predict that the Earth will warm between 2 and 6 degrees Celsius in the next century. And when global warming has happened at various times in the past 2 million years, it has taken the planet about 5,000 years to warm 5 degrees. So that rate is at least 20 times faster than what we've seen before. And so people always say to me, birds have dealt with climate change before, people have dealt with climate change before, but what's different is the rate. This is happening at such an unprecedented rate that it's very difficult to keep up with this amount of change. And so that's one thing to keep in mind. The other thing I really like to highlight is that when birds or other organisms in the environment have dealt with climate change in the past, there hasn't really been changes to the landscape at the scale that people have changed today. And so this is looking at housing density in the United States And essentially, the more housing density, the less natural spaces you have, the less natural vegetation. So the greener areas are more wild places. They're more natural. They haven't been changed. And then as you move to the lighter green through to the red and the dark red, these are areas that have lots of people and less natural areas. So going from 1940, 1950, you can see how it changes through time, 60, 70, 1980, 1990, 2000, and 2010. You can really see the presence of humans, urban areas expanding, agricultural areas expanding. We have really put change across the landscape, and these are the projections for 2030. And so what this means is that we have this landscape that's dominated by people, where in the past a bird might have changed its behavior or where it lived because of climate change, and it anticipated it would have seen a native prairie or a really intact forest system. When they're having to deal with it today, they're looking at monocultures of cornfields that used to be prairies. So they've been completely converted to a habitat that they're not going to be able to use. And instead of forest systems, they're seeing suburban areas or cities in areas. And so what that means is that if a bird needs to change where it lives because of climate change, it might not have the places to go to because they've been changed by people. So the rate of change and the fact that the landscape is so different and so not natural makes it really difficult to adjust to climate change. Now, I want to talk a little bit about the fact that climate change is not a far off future event. Climate change is something that is happening now and has been happening for a while. And so a lot of people just think, okay, with climate change, we're going to see changes in birds going up and down mountains or changing where they live. But there's a lot of other things that I want to talk about. And so what are some of the signals that we've already seen? So one of the things we've seen is that climate change is affecting birds' egg laying, so they're breeding. So it's occurring much earlier than it used to occur in the past. So for some species, up to nearly 7 days earlier per decade. The North American tree swallow are nesting 9 days earlier than they did 30 years ago. And in some areas like the Midwest, bald eagles are nesting up to 6 weeks earlier because the ice actually is melting earlier. And so all of this is happening because spring is coming earlier. Our winters are getting more mild. Things are warming up earlier. And so birds are actually adjusting when they breed because of these changes. Another really recent study has found that birds are actually changing their body size because of climate change. And so they've been shrinking through the decades. And this is a study across multiple species where they actually went into the museums and measured the birds through time. And they found that the birds are getting smaller and their wings are getting longer. And this is because as temperatures warm, the hypothesis is that birds' bodies are going to get smaller to deal with that heat stress, and the longer wings so that they can move and be a bit more flexible in how far they have to fly. So another phenomenon is changes in migration. So birds are migrating earlier. So some birds stay in place and live there year round. Other birds fly south for the winter and then come back in the summer. And this was a broad scale study. As data interested people, you'd probably be fascinated to hear that this study was done using radar data. So Doppler radar data can actually pull out bird migration and also insects. And because it can see when a bunch of birds or insects fly off the ground at one time. And birds generally migrate at night. So they all sort of take off from one place, and you can see these big pulses on the radar. And we've been using that for bird data for a long time now, and we can actually go back and pull out when birds are migrating. And they found that birds across the board, not just individual species, but across the board are migrating earlier in the spring as temperatures warm earlier. So this is causing some issues with mismatches. Because the birds are having to adjust to this rapid change in the climate, they're having some issues adjusting. And so where a bird might have arrived in the 1850s on May 6th, and then the trees started to get leaves on May 10th and flowers on May 15th, what's happening now is that the vegetation is coming way earlier. So the plants are responding to those temperatures. The birds aren't here yet. They're south somewhere, and they're having to fly north. So they're not realizing when these things are changing. And so the issue here is that once the leaves start to grow on the plants, cued by the temperature, that's when all the insects start to come too. And the number one thing that the birds depend on in spring are insects, because 96% of land birds feed insects to their young. So if they're not arriving at the right time when the insects are there, they're going to have a really hard time sustaining their breeding, their babies. And this is just sort of another graph that shows that what's happening is that birds are not arriving at the right time, and that the peak of abundance of caterpillars is shifted way earlier, and it's not coinciding with the most important time when they need to feed their young. So this is causing a lot of problems. I also want to highlight that whole communities are becoming disrupted. When you first look at this picture, it's kind of hard to see what it is, but these are actually dead seabirds that have all washed ashore, and they've died because of starvation. And this used to happen once every couple of decades. It's now happening every year, where tens of thousands of birds like common murres or puffins are washing up, particularly in the northern parts like Alaska, because they've had extreme heat events in the oceans, and that's changed the whole fish community. So the prey that they normally eat are not the prey that they're finding in their area, and so they're dying of starvation. And also distributions are changing, and so the majority of the rest of the talk I'm going to be talking about bird distributions. And so what that means is that, I don't know if any of you guys have seen a field guide, but if you open a book that's a field guide, it shows you a map. It's a picture of the bird or whatever animal you're looking at, and then a map. And it shows you where on the map that bird lives. So that's a species distribution, or its range, where it lives in the US or whatever particular area you're looking at. With climate change, they actually move where they live because they're trying to stay in these ideal conditions. And so we've seen species like the Carolina wren, the chipping sparrow, the hooded warbler move their ranges because things are changing already. And the last bird, the rusty blackbird, this species has actually lost a large chunk of its range. It no longer occurs there in the breeding season because it's become unsuitable based on climate. So this species is actually shifted 120 kilometers northward in where it occurs. And so just to give you like a little bit of context with biology, the reason why climate affects where a species lives is because climate affects the ability of a species to live. And so here we're looking at this bell curve, which looks at the abundance of an organism and its optimal range really in relation to temperature. And so what you see is in that optimum range in the middle, you have the most abundance of a species, because that's the temperature that physiologically their body is able to adapt to. But as you get to higher or lower temperatures, it starts to get stressful for them, and you get less and less of these organisms because they're not able to live in these areas. And so we can take this concept of temperature and how it affects the abundance of a species and kind of put it on a map. This is a really old map from the 1980s of where eastern phoebes occur in winter. So what this map is showing, and I'll show you this map in relation to it, is that you can see this hard line that says -4 degrees. This is the average minimum temperature. January temperature was called an isotherm. So that sort of delineates where the average minimum temperature in January is -4 degrees. But above that, it's colder. Below that, it's warmer. But what this is showing is that is a hard limit in temperature for this species. You can see on the map on the right, light pink is low abundance, and like the darker the red is the higher the abundance. So the further you get away from that line, the more abundant that species is, because that's the northern hard limit for that species. And so this is translating this map to, this figure to a map showing you where that species cannot occur based on its tolerances. And I just wanted to highlight that because this is the whole reason why climate change affects species and people, because we have tolerances, we have limits that we can't go past. And with climate change, all of this is changing. And these whole isotherms are changing across the landscape. The climate that you knew in your area is going to be very different. So New York City is actually going to be more like Kansas in terms of climate in the future. And so we look at this information, and these circles here represent individual species and how they've changed from the 1960s to the 2000s. And so the lighter blue dot is the 1960s, and the darker or brighter blue is the 2000s. And what this is showing is the center of abundance. So that optimal location for that species where it's most abundant across its entire range, how has that changed through this entire time period? And what we see for some species like the purple finch, that's shifted 433 miles. So that's like, this is just winters that we've seen. And as the winters are getting warmer, we're already seeing large changes in not only where these species occur, but where they're most abundant. So that's why at Audubon, we use this hashtag, birds tell us, because we look to birds as actually being messengers. So they are really messengers of what's going on in our environment. If you take something like climate change, it's a really global, abstract concept to sort of get through your head, like what's going to happen to me locally. But because birds are intimately tied to the world around them, we can look to them to see how things are already changing. And so those past slides I just showed you are already showing you that, yes, like climate change is happening and the birds are showing us, like that's not something that we can just talk about. That's something that people can go outside and see. So for example, the Carolina wren that I mentioned to you, my dad has been feeding his birds for 40 years in his backyard. And he told me a couple years ago, he's like, oh, I have this new bird at my feeder. And he said it's a Carolina wren. And this is a species that science has been documented that it's shifted its range further north because of climate change. But this is something that my father, as a birder, has just seen in his backyard and noticed. So I think that this is why birds are so important and nature in general, because it gives this lens, this unique local lens on climate change. So this is talking about what has happened. Now looking to the future, we're headed to a much warmer future. So of all these scenarios, we're most likely on the bottom two on the left of the temperature, which you can see are much warmer. So those are degrees temperature Fahrenheit warmer than current. And so we're headed for a really, really hot future in the US. And precipitation is going to change too. It's not just about temperature. And so the data that we use in our report that I'm going to talk about is a combination of different factors of temperature and precipitation. But this is showing you that some areas in the different seasons, some areas are going to be wetter and some areas are going to be drier. So here in the Northeast, we're likely to see greater single heavy rainfall events, which can lead to flooding. So another report that did not come from Audubon, but did come out in October, talked about how, I don't know if anybody heard about this report, but 1 in 4 birds have been lost since 1970. So 3 billion birds, we have 3 billion less birds in North America than we did in 1970. And so that is because of things like habitat loss, window collisions, people's cats outside. Cats kill probably the most of anything every year, about 3 billion birds are lost to cats every year, and pesticides. So lots of things have contributed to a crisis in terms of losing 1 in 4 birds since 1970. And so we already have all these issues that birds are facing, but when we shift to the future, we realize that there is a big issue here. So the 5th alarm and a 5-alarm fire. And this is what our report talks about, which I'm going to get into now. So again, it's called Survival by Degrees, 389 bird species on the brink. And so to get into some of the data, we used a really robust data set. And so what you're looking at on the right is just a snapshot of 10,000 of the occurrence records from different data sources, but we used over 70 data sources. And these data points, these dots, all represent an individual bird that has been seen at that location by somebody. And so it has the latitude and the longitude associated with the occurrence and the species name and the date. So each of these records came from somebody who went outside and collected they went outside and collected data on a bird. So this can be researchers, scientists, this can be government employees, but the majority of this data actually comes from the community. There are a lot of people who are able to and willing to go outside and collect data on birds, and we have a really impressive data set because of this. And so, like I said, 140 million observations. eBird is an app that you can go out and you can collect data. So you could see a bird out your window and then go to your phone, go to eBird and submit what you saw, and it will record it, and then researchers like me can use that information. So those are called community scientists or citizen scientists, and it's one of the best data sources that we have. So it's, as a scientist, I can be in one place I could go outside and count my birds, but because climate change is that happening at the landscape scale, we need data from everywhere. And that's why these sorts of data, crowdsourced data, are really important. So this is a really impressive data set on bird observations for North America from a diverse source of data sets to understand how birds are going to be affected by climate change. So if anybody has questions about the nitty gritty of these, I'm happy to answer them, but I wanted to kind of really show what came out of the models. But in order to understand where the birds are, we have the occurrence, but we also need to know what's the environmental information that is related to each location. And so we have data from different environmental factors that we know affect where birds occur. So we have climate. We have the data at a full North America extent at a 1 kilometer resolution, and we use a lot of our data comes from GIS. It's spatial data, so every single location has a latitude and longitude at a 1 kilometer resolution, and each of these squares or grid cells at a 1 kilometer resolution has information about these environmental features. And so for climate, we have several different variables of temperature and precipitation, different for summer and winter, so that we can understand what are those like tolerances for each individual species. And so we did this for 604 species, I forgot to mention on the last slide. We also have the same 1 kilometer resolution of human land use. And so this is data about where are there cities, where are there urban areas, where is there agricultural fields, where are there natural areas that are trees or vegetation or grasslands or prairies. So these are all based from remote sensing, so satellite imagery, and they can take that information to understand what is the land use in that particular area. So we have climate, we have human land use, we also have vegetation. And so these are broad vegetation groups like deciduous forests or grasslands, and how we have those for the current and also the future, how they're anticipated to change. So these broad vegetation groups, because a lot of bird species are tied to specific habitats. And then we also have specific variables that we've used for particular birds. So for example, we have a group of our water birds, birds that use water. And so this is a data set that has global surface water. So it's where do you see water on the landscape. This is another remote sensing satellite derived imagery. So they just pull out where there's water based on how it reflects back to the satellite. So some really cool ways of getting environmental data, but these are all related to how birds, where they live in the landscape. So what we do is we take the occurrence data and we take the environmental data and we put it together in what is called a species distribution model. I'm not going to go into that too much on the talk, but I'm happy to talk about it at the end if people are interested. But essentially, it kind of identifies, it kind of takes the occurrence point and drills down through all the environmental information spatially and looks at all of the points for a particular species and says, okay, what do they have in common? What are the sort of thresholds for the species? Where's that optimal range? And it makes this sort of picture of what the ideal environmental conditions are for that species based on the variables. And then it finds on the map, where do those conditions occur? So where are those ideal conditions of temperature, precipitation, land use, vegetation? And it creates a map. And so the map is generally, it's generally continuous where you see low suitability up to high, like the highest suitability. But here we've just sort of given a snapshot of, for the wood thrush example here, all of this area in yellow represents the range that is suitable above a threshold of suitability for this species. So we have this for the current, and we also have our future projections of how climate and vegetation are anticipated to change, so that we can project a future range of where that species might occur. We've linked this to different climate change scenarios. So these are 3 global climate change scenarios, 1.5 degrees, 2 degrees, and 3 degrees Celsius. And the reason we did this is because, as I mentioned, we're about a little bit over 1 degree now. 1.5 degrees was the Paris Agreement goal. 2 degrees is kind of where the IPCC is, that's the Intergovernmental Panel on Climate Change, is suggesting we should target now. Although 1.5 would be ideal, 2 might be more realistic. And 3 degrees is sort of where we're headed if we don't do anything, and that's a conservative We're probably a lot higher than that. But unfortunately, that's where our current policies at the federal level have us, about 3.2, and also the pledges and targets that different countries have put within the Paris Agreement have us at about 3 degrees as well. So we need to do a lot more if we want to bring things down. And I just wanted to highlight that the half a degree makes a big difference. So 1.5 to 2 degrees Celsius is actually 2.6 times more extreme heat, 10 times more or less sea ice, a lot more sea level rise, and then way worse in terms of species loss. So 2 to 3 times in terms of vertebrate, plant, and insect loss, large loss of permafrost. So that half a degree actually makes a big difference. So we would really love to keep things at 1.5 degrees if we can. So this is what the models look like when you project it into the future. We have that current range I showed you on the left, and then we have two scenarios that we're looking at here, the 1.5 versus the 3. So if you go to our website, which I'll talk a little bit more, you'll see this for all 604 species. Areas in red are areas that are no longer suitable. As the climate has changed, these areas are not suitable based on vegetation or climate anymore. And so these are the red areas. Blue areas are areas that the bird could potentially move into. They're not suitable now, but they could be in the future. And then orange is worsening, yellow is stable, and green is slightly improving. And so you can see here the difference, a lot more dramatic at 3 degrees for this species. And this is sort of cycling through, so you can see how it changes through the different scenarios. But I will say that at the 3 degree scenario, the wood thrush is considered highly vulnerable to climate change. It loses a large portion of its range. It's not really able to make it up in too many new areas. But at 1.5 degrees, the species is considered low vulnerability. It doesn't lose that much of its range. And so looking across all 604 species, looking at how much range loss there is to range gain, we found that 2/3 of North American bird species are at risk of extinction from climate change because of the large amounts of range loss that they're going to be seeing. And this includes 1/4 of state birds could lose the majority of their range in one season at 3 degrees. So that's like American goldfinch completely disappearing from New Jersey. So looking across, we broke this down by different habitat groups because not all, like I said earlier, some birds like water birds need specific habitat. So we also wanted to look at how the groups were going to be affected. And what we found was our Arctic and arboreal species were the most affected. They had 100% or 90 or almost 100% of their species in our 2 vulnerable categories, which are moderate and high. But you can see the majority of the groups that we looked at had more than 50% of their species at risk. And so these are our forest species, these are our water birds, our coastal species. The species that are least at risk are our generalist species and our urban and suburban species because they're a lot more adaptable to a range of conditions. This is just highlighting some of the species that are climate vulnerable, but they're also of species of conservation concern. 50 of our climate vulnerable species are already of conservation concern. Like for example, piping plover is a New York species that we have out here on Long Island, and they're endangered already, and they're anticipated to lose large amounts of habitat. So there's a lot of like pessimistic news here, but the good news and the hope is that if we can stabilize things at 1.5 degrees, we can improve the chances for 76% of the species. It makes a big difference. This is just sort of showing the 2 different scenarios. So what this is for every one of those grid cells, again, the spatial information here, it has the information on how many species are there and how many of them are losing range or gaining range in these particular locations. And so areas in red, really bright red, are areas where we're losing a large number of species, almost 90 species in these locations. And this is much more dramatic at the 3 degree scenario. But across the board in the breeding season, we're going to see a lot of range loss of species. You'll see a lot of the blue is concentrated in the far north in the Arctic. As species are trying to escape heat, they're going to move north because it's colder there. However, eventually they're going to run out of places to go. There's nowhere to go further north than that. So for me, common loon, this is a common loon. This is my favorite species. the reason it's my favorite species, as a birder, it's what's called our spark bird. I was in 2nd grade and I was visiting my grandparents in Wisconsin, and I heard the call. And if you've ever seen a horror movie, or they often play them in the background, is this like eerie, like it's just this enchanting call. I can't describe it. Gonna have to go Google it afterwards and listen to it. But it just sort of captured my attention. And after doing the study, I realized that that species was no longer going to be in Wisconsin anymore. It's going to pretty much not be breeding in the United States anymore. It's going to shift north to Canada. And that really got me thinking. Like, I had just been with my 5-year-old daughter, and I had showed her the bird, like the common loon in Wisconsin. We're not going to be able to do that anymore. She's not going to be able to show her kids that bird anymore. And so I think we have to think more than just the numbers. It's also people's connection to nature, connections with their family. Nature as you know it is going to change. And this is what this is about. This is more, it's not just that nature is changing, it's also the places are changing. So I think it's just important to keep that, that context. So I talked to you about the data that we used in terms of looking at where species were going to be in terms of range shifts. The second part of our report, we looked at other threats that face birds, but also that people also face in the locations that they share with birds. We wanted to look at these other climate change related threats. And so we looked at sea level rise and changes in lake levels. We looked at urbanization, which is also related to climate change, cropland expansion. And then we looked at measures of extreme events like heat, drought, fire weather, heavy rains, and false springs. And so any of these individually can be catastrophic for locations or for people, but we wanted to see how they were going to be affecting across the lower 48 states. And so these are just where we found these risks. And so the lighter orange is the 1.5 degree scenario, and the brighter orange is the 3 degree scenario, and they're sort of additive. So what you can see is that some of these threats actually are going to face a large portion of the United States. And so it's not just individual threats, it's not single threats, they're going to be seeing multiple threats in locations. And what we found was that at the 3 degree scenario, 305 species will face 3 or more threats. However, at that 1.5 degree, only 34 will. So that's these multiple threats at once. This is a map of what the multiple threats look like across the United States. So you can see the areas of bright red are areas that are going to see up to 6 of these threats at once in a given location. So a lot less severe at the 1.5 degree scenario. So this is where it pulls in the locations, the place, the people. Like, these are threats that we are going to be facing as well. So again, the message is clear that 1.5 degree scenario is where we want to be, not the 3 degree. These are some of our species that are affected by 4 or more climate change related threats. A lot of them are coastal, and that's because they're going to be facing extreme events, but also sea level rise and urbanization. And so when we look across the board at our study, every bird species that we looked at is going to have some effect of climate change, and that means every location where people live as well. And these are just areas that are really at risk of climate change because they have lots of birds, they have lots of vulnerable birds, and they have lots of threats. So here in New York, in the breeding or summer season, that's when we're most at risk of climate change. So we know these 2 pieces sort of help us understand what we need to do moving forward. We talk a lot about like mission-driven organizations and how we use data. So Audubon is really trying to bring the message that we need to protect the places that birds need now and in the future. So that's looking at places. And also we need to take personal actions, but we need to go beyond that. We need to take state, federal action to address the root causes of climate change, the mitigating the effects of climate change. So those greenhouse gas emissions I talked about in the beginning. So I was going to show you guys to take a look at it yourself, but we have a web tool where you can really look at everything. The web, I'll have it at the end, but this is where we really localize everything, and you can find out, you can search by your state or your zip code to find out how birds are changing in your area and how the threats are changing in your area. You can see which birds are vulnerable. In particular, like we can look at birds like piping plover in New York that are going to lose 100% of their range in New York unless we do something about climate change, and which threats are going to affect your area. can see different species that are going to have range loss. And then, but this is where the message really becomes what we need to do. And so we need to take two different actions. So the first is that protecting the places. This is climate change adaptation. And so this is looking at what you can do locally in terms of habitat restoration that is going to help birds and places be resilient. So New York in particular is very, very vulnerable to flooding and sea level rise and hurricanes. And so can we look to restore wetlands that will help buffer the effects of climate change? And there are some communities and some organizations that are working on that in New York. So getting hands-on and helping with things like these restoration efforts or protecting different areas. You can also think about planting native plants in your area, which is great for in parks in particular. These are really great things. And so that's one thing. We also have to think about mitigation. So this is addressing the greenhouse gases. So coming up with 100% clean electricity, looking for natural climate solutions. So these are things that will pull carbon out of the atmosphere. One of the things that Audubon is doing is a program called conservation ranching, where we're working with ranchers to graze their properties in a way that's good for birds, and it's also good for climate because it stores carbon. And so they rotate their cattle, and then they're selling that meat as Audubon certified bird-friendly meat that's also good for climate change. So we need to think about these sort of natural solutions, planting forests, doing stuff in our green spaces, and then energy efficiency, clean transportation, and innovation. New York is doing pretty well with climate policy, and I know we're close on time, so I'm not going to talk about that, but this is what I wanted to get to on this slide. So this is just a screenshot of what our climate action guide looks like at Audubon. I can share the link with you, Elaine, afterwards, but it has a lot of really great information on different things you can do locally on climate change, from starting the conversation, which is sort of our first level, which means talking about climate change, not making it this taboo subject, but talking about it in a way that relates to you. So for me, it's birds. I can talk about climate change through the lens of birds, but if you're like a skier, you can talk about how there's going to be less snow in the future. And so talking about starting the conversation and talking about things and relating to people's values and things that they care about. You can start to lead your community. We can think about rebuilding the machinery, which is like getting to clean energy solutions, or you can start to join these national causes or different things that we need to get to at a federal level. So I'm going to get into a little bit of this, but not a ton, but I think you need, like, definitely look at our climate action guide. There are opportunities to talk to your legislator. I think that the most important thing we can do is be vocal about it. So write to your editor, talk to your elected officials, local, state, and federal, and say that this is an important topic for you. And again, use those values, like what are the things that you can connect with. And I think, again, going back to birds, it's a great way to localize climate change and to be able to talk about it through that lens. And so that's why that tool really is helpful, because it localizes it. You can show what's going to happen in your community in terms of these climate change related threats as well as birds. And so those are one things. You can also advocate for more native plants in your parks, like I said, because this is sort of a win-win, because you get native plants that need to be mowed less and watered less, and they also absorb carbon, and they also absorb like flood water. So they're kind of a win-win to get them into your parks and your areas. And I've walked through Brooklyn and see beautiful little native gardens just on the side of the road. So I think that there's different opportunities for that. Composting is really important, and food waste. One of the biggest causes of greenhouse emissions is food waste. And so talking to your local grocery stores about where they're throwing their produce out, and if you can donate it instead of it going to the landfill and then releasing lots of greenhouse emissions. Another thing that you can do from a personal action is to eat less meat, because cows in particular are really bad about releasing methane into the atmosphere. You can also get involved with birds. So there's different opportunities within Audubon if you're interested in birding, including the Christmas bird count or climate watch. This is really important. Like I said, I wouldn't be able to do this study without people going out there and collecting data. So yeah, so that's another thing you can do. This is the High Line in New York City. This is Audubon has a program called Plants for Birds. And so I think that this is a great opportunity to go and see what people have done with native plants, and you can find out around there. And I will leave this here, that New York City Audubon is a great resource. They do a lot of really cool stuff. They have campus chapters, and they do advocacy. So if you want to get plugged in with somebody who's doing like really on the ground grassroots climate change action, I would definitely check out New York City Audubon. So those are just some of the things that we talk about, and definitely check out that climate action guide because it's got really specific things you can do on the different levels that I talked about.
Great, thank you. Thanks so much. Okay, question here regarding the planting. Should we plant toward the trend of increased temperatures and decreased water versus traditional native plants that may not survive in the changing climate?
Well, the good thing about native plants is that they are a lot more resilient than some of the cultivars that come from other countries. And so they tend to be more drought resilient and can deal with the environment a little bit better. So I think that in terms of climate change, native plants are actually a better way to go. And they're better for like I said, climate change in general, in terms of they store more carbon and they're more resilient. They need less maintenance than some of our cultivars. So I certainly think native plants are the way to go. Okay.
I'm going to read this last question here because I just have concern about the internet connection, and maybe you can follow up with Brooke as well. Her email address is here. For the 140+M observations, do you trust the data reported by the community? Do you trust that it was accurate? Is it not easy to recognize bird species flying by the windows, at least? It is not easy to recognize bird species flying by the windows, at least for me. This came from an audience.
Yeah, so the majority of people that are submitting data are pretty familiar with birds. There are over 50 million people in the US that consider themselves birders. And so I think the majority of the data are pretty good. The people out there know what they're doing. eBird in particular actually has a check system where they have reviewers review every single checklist that comes in. And if there's anything weird that shows up, they will flag it and it won't go into the system. And so there are a lot of checks built into these systems. In terms of the models themselves, we have done our best to address any bias that are in the data. So a lot of data sets often are biased to where there are people, because that's where people are. So addressing that, we're gonna have more records near communities with lots of people, near roadsides where people are gonna be going. So we build that into the data itself. We correct for that bias. And there are checks put into the systems of where we get the data from. So probably it's not all perfect, and there are going to be some points that are wrong, but the signal does come through the noise, especially when you account for all those different things.
Great. Well, I'm going to end on that question because we have gone over a bit. Brooke, thank you again for a fantastic presentation and inspiring us. And I want to thank everybody that joined us tonight for this virtual meetup. I enjoyed it. I hope you did as well. I hope you found it informative. We hope to have another meetup in May as well. Plans TBD. Some of our speakers want to see what happens with in-person opportunities, but we have some that express interest. So I'll be in touch with you, but we do hope to shoot for May. Thank you all, and we will be in touch about our next one. Have a great evening, everyone.
Thank you.